Welcome to week 2 of our software security course. Again, I'm Chris Tyson, and this is Ted Zhu. We're going to be doing our roundtable today without Dr. Williams, unfortunately. She couldn't make it today. So without further ado, why don't we talk about our first breach?
So last week, the FBI issued a warning about a potential security breach with a technology known as FTP, which is used to send files from your own computer to a file server. And this is most relevant if you're actually a developer of a website. This is the file transfer protocol that you use to upload new websites and new files and other images and things like that. And it turns out that if you do a default installation, it will allow a type of authentication known as anonymous or just basic FTP. And with that, you wouldn't even need to use a proper username or password to prove your identity when you're uploading new content or downloading files from the web server.
Right. So one of the issues here really is this idea of a broken authentication system, which follows the theme of what we talked about last week in our second module. The idea of making sure your systems are secure by default, and that all these types of accounts and settings and things like that aren't there when you install these programs in the first place. So in this particular example, they talked a lot about the healthcare domain and about how healthcare companies were really being targeted right now. And you saw a similar thing happen with Internet of Things devices. So if people heard about the cloud hack that happened where a bunch of malware got loaded onto cameras and thermostats and other devices you don't really think of as computers necessarily, and used to execute denial of service attacks against people.
And the thing about this is that we have manufacturers making these servers and other Internet of Things devices, and they're really using default installation options. And because they're manufacturing so many different devices and controlling so many different servers, they all have the same copy of the insecure configuration settings.
Right. So one of the things we'll be talking about later in the course is this concept of secure by default. So and that's basically saying that people aren't necessarily going to check to make sure that their applications are set up in a secure way necessarily. They're just worried about getting the functionality there first and then security later. And so it's important whether you're developing software for healthcare companies or software for cameras or thermostats, is that your default setting, you need to balance usability and security. I think that a lot of times people these days are focused a lot more on the utility and not so much on the security. And we're starting to see kind of the consequences of that now.
And usually with these web servers, they have these web application technologies have developer mode and production mode. And so when you first set up your website, you're going to use developer mode because that gives you the most amount of information possible and gives you useful log information and debugging errors and things like that. And those will also have the least amount of security just to try to get the connections working. But then the common thing that's been happening is that these developers move their development mode into actual servers out to the public. And that's instead of doing what you really should be doing, which is use production mode, where all the security settings are at its harshest or most strongest configuration setting.
And we saw that last week with the GitHub exploit too. That was one of the direct reasons that happened, is because a developer flag essentially was set in a production environment. Yeah. So moving on, the next thing we want to talk about is something that's been in the news a lot recently. So the concept of machine learning to drive all sorts of different devices and other things in our lives today. The second article we're going to talk about addresses the problems with machine learning as it applies to self-driving cars. It's obviously a big topic. We have big companies like Uber and Google working on this, so we can completely change the way we approach transportation. So the way these cars work, and if I give you a 30-second explanation, and there's a lot more information that the link will provide for you, is that we build up an experience with these self-driving cars. They learn from their previous actions. They learn from what other self-driving cars would do. So they know that when they see a stop sign, that is a stop sign. And they do that by processing hundreds of different images of stop signs. One of the things that a lot of these approaches take for granted right now is that all of these, what they call training sets, are intrinsically supposed to be beneficial for the system. If something is presented as a stop sign, it is going to be a stop sign. One of the things that people working in these fields are starting to think about is what happens when people don't necessarily have the best interests of the device at heart when they're providing these training sets or out in the field. One example that was brought up, that is brought up in this particular article, is the idea that hackers, quote unquote, could put up signs throughout a city that they know self-driving cars are in that are explicitly designed to trick the car into thinking it's a yield sign or a traffic sign that it wasn't supposed to be there, or even worse, actually corrupt what the machine knows about a specific sign. So it would start thinking, because it saw this particular sign, all the stop signs are now yield signs, is the example they use in the paper, which obviously has pretty severe consequences.
Another way that machine learning is used practically is with image recognition of wildlife creatures like animals and plant life. And this is something that wildlife researchers will use to track animals, their populations, and their migration patterns. But one way that attackers could subvert this type of engineering, for an example, poachers could be interested in trying to alter the data for what the true population size of like the African forest elephant. And they could do that by just sticking images of elephants around the property, or other ways that they've determined that the machine learning could detect and interpret as an elephant.
This is obviously a machine learning course, so we're not going to dig too much into the details of how that works. But let's talk about what this malicious input means. So traditionally, security folks think about buffer overflow exploits, injection attacks, as we talked about last week. We think of it as text. We think of it as input, as someone sitting at a computer, maybe in a dark room with the screen shining on their face, is entering to hack all of these different machines to get money out of banks or get your healthcare data or things like that. But really, malicious input could take on a lot of different forms. And you can definitely see how parties would be interested in causing self-driving cars to drive off the side of the road. Competitors could be trying to prevent their competitors from having a good reputation. Terrorism is a common one that comes up. So thinking about malicious input, not only in the sense of someone sitting at a computer typing code, but also what is being fed into these more dynamic systems we're developing is something security professionals are going to have to start thinking about in the near future.
And so, rather than just letting a computer learn what a stop sign looks like, it also, the security researchers are now trying to train computers to learn what stop signs don't look like explicitly. And by doing that, that'll help prevent the different hacking attempts that attackers will use to try to take, a sign that we obviously look like maybe like a yield sign or a pedestrian crossing, but you alter a little bit of the features of the image, and that might be misinterpreted by the computer.
Right. So, I mean, the big takeaway here for you folks in this course is really important, even if you consider yourself the defensive security professional. It's really important to be able to get into the mindset of what the attackers are going to do. You can't really defend systems unless you know what the attacker is going to do.
And this is a really good example for how machine learning is not as ready as we might believe it to be, or as ready as we want it to be, just because of all the different inputs that it could potentially take on, and since it's training itself, it could really learn a new set of rules that we didn't expect before.
Yeah. So that's going to do it for our Roundtable this week. We've got 2 more great modules from the OWASP Top 10 for you this week, and hope you enjoy the material, and see you next week.
Thank you. Bye.